Hi guys, let's continue with solving our task, and the next task would be the following. Number of dice rolls with target sum. So you are given an n dice, and each dice has k faces numbered from 1 to k. Given three integers, n, k, and target, return the number of possible ways out of k over n, total ways, k, to roll the dice. So the sum of the face-up numbers equal target. Since the answer may be too large, return module 10 over 9 plus 7. Okay. So here we have 6, right? And we have 6 power of 1, it would be 6, and target 3. So you throw one die with 6 faces, and there is only one way to get sum of 3. Yeah, that's true. If I have 6 faces and you throw 2 dice, right? And each with 6 faces. So how much options I can give? So, for example, let's take a look. So let's say I have one dice and it has 6 faces. So I can get 1, 2, 3, 4, 5, 6, right? Then I have another dice and it also has these 6 faces. Then I have some target, for example, 7. So how can I get 7 from 2 dices? I can get 1 and 6, right? Or I can get 1 and 6, or 2, 5, 3, 4, no, 1, 6, 2, 5, yes. Then 3, 3 I cannot get, so 3, 4, 4, 3, then 5, 2, and 6, 1. So in total, I have 6 options that I can get. It's actually correct answer. And if I have 30 dices with 30 faces, right, up to 30, and I have like target 500. So in this case, I can iterate over each of dice, right? Then over another each of dice, then over another each of dice, like this one, and so on. So I have like here 30 dimensions. So with 2 dimensions, it's understandable. Actually, with 2 dimensions, I can build a kind of table and then just check the number of sums that I can get. With 30 dices, can I build a table? Let's check. So if I have, for example, 30 here, and here I have another 30. Yeah, and so when I have 1, something like this, yeah. So when I have 1, 1, it would be 2. 1, 2, 3, 1, 3, 4, and so on. So it would be 2 dices. 2 dices, right? Yeah. It's not possible. So probably then we think about backtracking. So when we take 1 dice, right, for 1, and then we have 29 other dices, and I do the same for the, yeah. Same for other 29 dices. So what I can do like DFS, right, with current dice, then with number of dices, current sum, number of faces, and target. Okay, and then I have like integer DFS. So here it would be die, number of dices, sum, k faces, and target. So if my die is equal to number of dice to n, then I check and return sum equal to target, this one. Okay, otherwise I have a result. I iterate over while n number, while die is less than n. Okay, and this die also I should iterate while. So I have 2 loops, and I have current sum, and I have key faces. So I need to do like iteration from, so faces is from 1 to k. Okay, and here I just call this DFS. And also if sum is greater than target, I just return 0. So this is DFS. I should call die so I start with 0. So it should be n minus 1. Here die plus 1. Then a number of dices would be n. Then current sum, it's my sum plus die. Oh, no. Die, it's number, it's current die. Okay. Yeah, it's number face. So let's say I have 1. Face 1. sum sum. Yeah, 0. Okay. Then I have key and target. And here I add in this to result and return results. Okay, and here I return this one. I believe I should also add memorization here. Time limit exceeded for 10 and equal to 2. 16326. Yeah, let's maybe like this. Check. Okay, target 3, output. Okay, so what is the problem? So I have n equal to 1, so 1 die equal probably. Let's check. Time limit. Okay. So I have DFS. Some target. Some from I to 6. So in result I should get this one. Yeah, let's print and check die. And it's always the same. Let's check sum, and key is the same. Target is the same. Okay, so I have die 0, then I have die 1, sum 1. Okay. Die 1, sum 2, die 1, sum 6. Okay, and why I'm not going out from here? Okay, so here I should also update this die plus. Output limit. Yeah, it's for this big test. Yeah, so time limit for this big test. But do we have the correct answer without this test? Just let's check. Yeah, so correct answer we have, but we have a really big test. So with this big test, actually what we can do, we can present some memorization and yeah, and just have for some die and number of dice, we have some yeah, it's a good question. Like, how can we store? Yeah, maybe we can have like a key. Let's create a key as a string and integer result. We have this map, so it would be our memo map, and then we have string k here, and for this string k we would have something like I k. Yeah, maybe die, like previous key, and die plus value, maybe something like this. Die and value. Okay. Yeah, so we are ending every time in the previous key. And here we have something like this. So we have die of 1 and some plus I. And then we have like a big K, and when it's equal, then we just put in our map K K. No, not here. Not here. Result. And here, if k, if map get k not equal to null, return map get k. Check. Yeah, and here we need empty string. Let's check. Okay. Yeah, it's still time limit exceeded. Time limit exceeded. Yeah, let's check some hint. Use dynamic programming. The state are how many dice are remaining and what sum total you have rolled so far. All right, so for example, can I add like if I'm on some current so for example, I have k, right? Yeah, I have n minus die, so it's number of dice remaining, and the maximum that I can get from each of these die is k, right? So if my sum is less than this k, than this value, then I can just actually calculate this result. Let's check. Yeah, still exceeded. Maybe not even this one, but this. Okay. Yeah, let's check solutions. Organization. Memo. The target. Target. What is the Tom DP? Target. DP. Dimension. What is D? DF. Okay, bottom up. Okay, so I think that's it for today. Thank you very much.